Good morning, or good afternoon, or good evening, I guess, depending on what time you are with math for me today. We are here ready to work on our next math lesson. So today we are on math lesson 3 of our new module. So we are on module 4, unit 4. And remember, yesterday we started working on area. And just as a reminder from what we did yesterday, so area is using square units, square tiles to fill up a space to see how many square units. Could be square inches, square centimeters, square feet, square yards, square miles. You can really use any unit of measure to find the area. Things that we can find the area of. So yesterday we talked about finding the area of small things like this Post-it note. And we found that it took, when we filled it all up, it took 9 square inches. These are our square inches or square units to fill up this Post-it note if I were to keep going. We talked about we could find the square footage of a floor, and we noticed like a lot of floors like in classrooms are tiles, so they're already in square units. If we have kitchen floors that are tiles, you can count the tiles to find the square units of your kitchen. If you have tiling in your bathroom, you can count the tiles to find the square units of your bathroom, and just you could measure to figure out they wouldn't be centimeters or inches because those are small if we're talking about bigger tiles, right? So but anyways, those are some examples. You could also find, if you have like a bulletin board, you could find the square units of the inside of that. You could find the area of that. Any enclosed shape, really, you can find the area of the inside of it by measuring in square units. So we're going to continue working on that today. So for your materials today, we're not going to do a lot with our tiles today, but you may want them to just practice with. So it would be a good idea to have your tiles. So you should have square inch tiles, if you remember from yesterday. And you could have your square centimeter tiles as well, handy. Let's see what else. You are going to need, let me get rid of the Post-it notes. You will also need your lesson 3 problem set. And you're going to need some paper, some grid paper. So you should have this sheet right here. This is your square centimeter paper. And then that is your square inch paper right there. Okay, so you need your lesson 3 problem set, your square inch grid paper, and your square centimeter paper. Okay, so if you need to pause the video and grab that, and then I'll meet you back here in a minute. Okay, friends, so if we are ready to roll, so like I said, today we are on lesson 3. So, and our objective today is that we are modeling with centimeter and inch unit squares as a strategy to measure area. Okay, and our I can statement, I can use centimeter and inch unit squares to measure area. So just kind of continuing and building upon what we started working on yesterday in our new unit. All right, before we jump into our problem set, I want to just do a quick little review of what we did yesterday. So I have a few slides where we're working on finding the area of the rectangle. So if we look at figure 1, what is the area of the rectangle? So a couple different strategies. You could just simply count the squares, right? So we've got 1, 2, 3, 4, 5, okay? Or I could, just like we would do with an array, I could label my side lengths. So there's 1 row, and there is 5 in each row. So 1 times 5 is 5. So the area of the rectangle, both methods that we used would be 5 square, and it doesn't tell us what unit it is, so we would say 5 square units. So remember yesterday we talked about if it doesn't say if it's square inches or square centimeters or square feet or whatever, we would just label it as square units. And SQ is the abbreviation for square, and UN is the abbreviation for units. Let's look at the next one. What's the area of the rectangle? Pause the video if you need to, or just do it right now. What is the area of this rectangle? Again, we could simply count the tiles, 1, 2, 3, 4, 5, 6. We could measure the side lengths, right? There's 2 rows times 3 in each one. So the area would be 6 square units. What do you think? Pretty easy, right? I can get the next page. take a look at that rectangle. Find the area of that rectangle. Did you find that the area was 8 square units? And which method did you use? Did you count the squares? Did you multiply the side lengths? If we count the squares, we've got 1, 2, 3, 4, 5, 6, 7, 8. So that may be the strategy that you used. Maybe you multiplied your side lengths. There's 2 rows, 1, 2, times 4 in each row. So 2 times 4 equals 8. So either way, we get 8 square units. So again, area, how many square units does it take to completely fill in the inside? And remember, we don't want any gaps or overlaps. Oh my goodness, my hands are so dry. That's the same one. I shot the same one twice. Let's see, there's a different one. Find the area of that one. Did you find that the area was 12 square units? Good. Again, we could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I could just simply count them. And when you have it in front of you, it's nice, especially if there's more, just to put a little dot on each one, just like I just did. We could also measure our side lengths. 2 times 1, 2, 3, 4, 5, 6 equals 12. So we would have 12 square units there. Okay. So I hope that's sticking. Oh, one more. Yes, that is different. I think it's one more. Yes, just one more. So go ahead and find the area of that one now. If you need to pause it, you can pause. For this one, since it's a little bit more, I'm going to do my side lengths, measure my side lengths. So 1, 2, 3 rows times 1, 2, 3, 4, 5 in each row. And I know that 3 times 5 equals 5, 10, 15. So the area would be 15 square units. And if you're writing these down, we want to make sure that we put that label in, okay? Because when we have area, we definitely want to include that label, because if it's not square units, if we know it's square inches or centimeters or whatever, that's definitely important. So we can see that when we have area, especially, I mean, this isn't a ton, but as we get to bigger shapes with bigger areas, if we can measure those side lengths and just simply multiply, that makes it a lot easier and faster, as long as we know our multiplication facts, right? Okay, so that was a little warm up to warm up our math brains. So now we are ready to jump into our problem set for today. So again, make sure you have lesson 3 problem set in front of you. Go ahead and put your name and date on there and show me you're ready to roll. Okay, so the directions say that each square is 1 square unit. So it's not telling us if it's square inches or square centimeters or whatever. So we're labeling as 1 square unit. What is the area of each of the following rectangles? So if we look at A, we want to find the area of A. I can count and just to see how many squares it takes to fill up, right? So just, you can do this with me, just like I was doing with our warm up. Just put a dot on each one as you count. 1, 2, 3, 4, 5, 6. So I know that A is 6 square units. Again, just like when we're working with arrays, I have 1, 2 rows, so label this with me, times 1, 2, 3 in each row, and I know that 2 times 3 also equals 6. So there's 2 strategies there for us. All right, look at B, and let's find the area together of B. Let's do the counting strategy first. So let's touch each square of B, and we can count together. So you count with me? Okay, here we go. Touch each square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So B equals 12, and it's square units. So we'll put the SQ for square and the UN for unit. So that's just the abbreviation for square units. We can label our side lengths too. And I say we can, but I want you to do that, boys and girls, to get in the habit of that practice, okay? So 1, 2 rows times 1, 2, 3, 4, 5, 6. There's 6 in each row. Okay. If you want to go ahead and try C and D, you can pause your video and then come back to me afterwards. Okay, so for C, I'm going to touch each square so you can count along with me. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it equals 12 square units again. So that's the same as B. So B and C have the same area. They look different, right? So they look different, but they actually take up the same amount of space. Let's label our side lengths for C. So we've got 1, 2, 3, 4 rows times 1, 2, 3 in each row. And that works out. That's a good check for us because we know that 4 times 3 equals 12. Okay. And then for D, did you get C correct? Same thing as me, 12? Good, because we're talking together. So D, if you count with me again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So D equals 20 square units. And if you labeled your side lengths, which you definitely should, right? We have 1, 2, 3, 4 rows times 1, 2, 3, 4, 5 in each row. So again, this is a good check for us. 4 times 5 equals 20. So we know that we are correct with that. Okay, good. All right, number 2. So number 2 says each square is 1 square unit. So again, each one of these squares represents 1 square unit. What is the total area of each of the following rectangles? So you can pause your video. This is the same thing that we just did up here. I want you to practice both strategies by touching and putting a dot to find the area as well as labeling the side lengths. It's just good practice, okay? So pause your video and then come back and check with me. Okay, so we're checking together. So A, we have 1, 2, 3, 4, 5, 6, and you labeled your side lengths. You have 3 rows times 2 in each row, so that would be 6 square units. Make sure you have that label. If you just put a 6, boys and girls, you're not done. Go ahead and add that square units right now, okay? Because we need that label. Give me a thumbs up if you had that correct. Okay, let's see how you did for B. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we had 1, 2, 3 rows times 3 in each row. So that equals 9 square units. Again, make sure you have that label. Make sure that you labeled your side lengths as well. And give me a thumbs up if you had 9 square units there. Good. Okay, look at C. All right, let's see how you did there. So when we're going to touch and count with me again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And we had 4 rows, right? 1, 2, 3, 4, and 4 in each row. 1, 2, 3, 4. So 4 times 4 is 16, so that's a good check. I know I'm going fast here, but you should have already done that, right? So we're just doing a quick check. So 16 square units. Again, make sure you have that label. Super important with area. And let's see how you did with D. Will you speed count with me? Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 square units. I need to label my side lengths. There's 2 rows, right? And then there's 1, 2, 3, 4, 5, 6 in each row. So 2 times 6 equals 12 square units. Give me a thumbs up if you have that. Give me 2 thumbs up and dance them around if you had all those correct. What do we think? Is this kind of easy or pretty easy? Or, yeah, it's easy, Mrs. Gruelle. Good, but it's fun too. All right, if you need to pause it to finish up anything, go ahead and then turn the page. All right, so 3A says, how would the rectangles in problem 1 be different if they were composed of square inches? So how would the rectangles in number 1 be different if they were square inches? So if we look at the rectangles in problem 1, they're small, right? So even though it says to label them as square units, they were like centimeters, so they were small. So if they were square inches and they were made up of those, so here's where we could use our tiles, right? So the first one for 2 times 3, let's make that with your square inch tiles because I asked you to have those handy. So that would be 2 rows and 3 in each row. That's quite a difference, right? Between this one right here and this one right here. Try to have no gaps or overlaps, right? So if it was made of square inch tiles, it would be way bigger, right? If it was made of the square centimeter tiles, or even what we see right here with those small tiles, it's a lot smaller. But if we made it out of square inch tiles, which we did right there, it would be quite a bit bigger. Okay. So that's what we can say. So how would the rectangles in problem 1 be different if they were composed of square inch tiles? The rectangles would be bigger. Right? And I made that with capital letters to show it's way bigger. Okay. What if it was composed of, so here's square inch tile or square centimeter tiles, square inch tiles. What if they were square feet? So what that means is think of a ruler, and I don't have one handy right now to show you, but a ruler is 12 inches, right? So it would be 12 of those for each side. So each side would be, we think of a ruler as about that big. Each side length would be 1 foot long. So it would be this long this way, and then this long this way, and the top would be this long. So that would be way bigger, right? So we would have square centimeters, square inches, square feet would be way bigger. If you think of a yardstick too, which I can't even, it's way bigger than I can show you on here. But if you have a yardstick or can imagine a yardstick in your head, if they were square yards, that means that all sides of the square would be a yard long. So that's very long too. Square miles, each side of the square would be a mile long. So we can count square units area in all kinds of different units. Okay. All right. Here's where you need your grid paper. So remember I told you to have your grid paper handy. So B says to select one rectangle from problem 1 and recreate it on square inch and square centimeter grid paper. So you need to have your square centimeter paper and your square inch paper. The square inch paper is obviously bigger. I'm going to do my square inch first. Okay. And it says to select one problem from problem 1 and recreate it on square inch and square centimeter paper. So if I pick one problem, I don't need the other pages attached to there. So let's say I want to do C. Okay, so C has 4 rows of 3. So C has 4 rows of 3. I'm going to recreate this on my square inch paper and my square centimeter paper. You can choose C or you can choose A, B, or D. It's up to you. You don't have to do the same exact one as me. So choose any one of these, A, B, C, or D, and then we're going to recreate it on your square inch paper and then the same one on your square centimeter paper. So I chose C, and I'm going to write this right here just to remind me that it's 4 times 3, 4 rows of 3. And so it's 4 rows, and I can have this right here to help me if I need it. So I'm going to go down 1, 2, 3, 4. I'm going to go down 4 square units. So we'll start here. 1, 2, 3, 4. So I'm going down 4 square units to match that. And then how many am I going to go across? 1, 2, 3. Again, you can do the same one as me, or you can choose to do a different one. 1, 2, 3. And then I'm going to come back down 4. 1, 2, 3, 4. Try to stay right on the lines, right? Because when we're dealing with these, they're not all over the place. They're not in the middle of a square. They're right on the square. And then we're going to connect the bottom. So it's 3 across. Okay, so this was C, and it has 4 rows. 1, 2, 3, 4. And it had 3 in each row. So there's that. What do you think? Did you recreate C2 or did you choose a different one? All right, so now I'm going to do the same thing, but I'm going to do it on my square centimeter paper. So what do we think about here? Is it going to be the same or is it going to be different? It's going to be different. It's going to be a lot smaller, right? So again, I can have this here if I need it. So it's 4 rows. So I'm going to stick it right up here and I'm going to go down 4. So 1, 2, 3, 4. And it's across 3. 1, 2, 3. And down 4. 1, 2, 3, 4. And connect 1, 2, 3. And this is C. And there's 4 rows with 3 in each one. If you need to pause to finish up yours, you can go ahead and do that. definitely a difference in size, right? So when you're done, you can kind of put your two shapes side by side, just like I'm doing. And the inch paper is way bigger than the centimeter paper, right? For sure. Okay, so again, if you need to pause to finish that up, you can do that. Okay, so I'm just looking at this, recreate it. I did that. It's not telling me to do anything else. So I'm just going to put a check mark there. All right, so this says use a separate piece of centimeter grid paper, draw 4 different rectangles that each has an area of 8 square centimeters. So I'm not going to use a separate paper because I still have a lot of room on that one, right? So we're going to use that same grid paper. And I want 4 rectangles that have an area of 8 square centimeters. So do you remember yesterday that when I talked about, we can use tiles for this. You could take out 8 tiles, 3, 4, 5, 6, 7, 8. So you could take out your centimeter tiles as one, and you could just build and see what you can come up with using 8 tiles to see what you come up with. Make sure that obviously we have an equal amount in each row. Another strategy that I showed you yesterday is we could do blank times blank equals 8. So since we know the area is 8, I can write my number sentences and have them equal 8. So blank times blank equals 8. Blank times blank equals 8. Blank times blank equals 8. And blank times blank equals 8. Okay, so if you want to pause your video and see what you can come up with, or you can work this way, you can work this way and build, or you can do both, right? Okay, so if you want to pause and see what you can come up with and then come back to me and then we'll see what we've got together, okay? All right, so I'm hoping that we did a little exploration to see what you could come up with. So one way that I told you yesterday is using tiles. We could just start creating, right? So I'm going to have 2 rows, and then I'm going to see if this will work out. I'm going to keep putting 1 in each row until I've used them all. So 4, 5, 6, 7, 8. So that works, right? Remember yesterday when we were working with these have like little connectors on the end, so they won't stick right together, but we're pretending that there's no gaps in there for mine. If you're using your paper tiles, they should go together nice and easily, right? So here's one way that we can get 8, right? So it has 2 rows times 4 in each one. Okay. What if I took this and, if I can just turn it this way? What would that be? So this way, I would have 1, 2, 3, 4 rows of 2 would equal 8, right? Did you come up with another way? So let me try this. So if you're trying and you're kind of exploring, maybe you are going to say, okay, I'm going to put 3 rows. And you keep adding 6, 7, 8, and then you get there. Is that one going to work? That doesn't work because I don't have equal rows. I don't have the same amount in each row, right? So I can't do that. So that's how you can kind of explore. You can try just setting up your different rows or putting a certain amount in rows and see if you can recreate that in your rows, okay? So we already did 2 rows of 4. We already did 4 rows of 2, so maybe you're going to continue to experiment. If I want 5 rows, I can't do that, right? Because I wouldn't have enough to do that. Do you remember that the other way that I told you yesterday that a lot of times people forget 1 row, right? If I have 1 row of 8, 1, 2, 3, 4, 5, 6, 7, 8. That's one that we forget a lot of times. So let's tuck that one in our head or in our pocket so we don't forget, okay? If I have 1 row of 8, so 1 times 8 equals 8. And the same thing, if I use the commutative property and I flip-flop, get my camera there, if I flip-flop those two, I don't know if I'm going to be able to, yay, there we go. If I just take that and turn that whole thing, now instead of 1 times 8, I have 8 times 1 equals 8, right? So yesterday we were trying to think of combinations that we could use that we wouldn't be using the same numbers again, more than once. But for an area of 8, there's only so many combinations that we can use to get 8. So if they want us to have 4 combinations, we would have to use the commutative property for 2 times 4 equals 8, flip-flop it using the commutative property to 4 times 2 equals 8. If we have 1 times 8 equals 8, we would have to flip-flop it to get 8 times 1 equals 8. That's how we would be able to get those 4 combinations. All right, so now that we have those on there, they want us to draw these rectangles on our centimeter grid paper. Okay, so I'm just going to kind of stick that there. The first one is 2 times 4 equals 8. So I'm going to go down 2. So put these on your paper too. I'm going to go down 2 and over 4. 1, 2, 3, 4. Make sure we're putting them on our centimeter grid paper. They definitely wouldn't fit on our inch grid paper, right? Because the inch paper, we didn't have a lot of room left on that. So 2 times 4, there was 2 rows of 4, and that gave us an area of 8. So I'm just going to stick an 8 square centimeters on the inside there to show our area. I also said 4 times 2. We also said 4 times 2. So I'm going to go down 4. 1, 2, 3, 4. Over 2. Down 4. Stay right on the lines. Nice and neat. 4 rows times 2 in each row, again, equals 8 square centimeters. Okay. And if you're not right with me here, that's okay. We're just going to draw these 4 rectangles, okay? Then we had 1 row of 8, so I'm going to come down 1 and over 8. 1, 2, 3, 4, 5, 6, 7, 8. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8. Down 1 and then connect again. 1 row times 8 in each one equaled 8 square centimeters. Good there. So I did 2 times 4. I did 4 times 2. I did 1 times 8. And then I'm going to do 8 times 1. So for that one, that means since 8 comes first, that's 8 rows. 2, 3, 4, 5, 6, 7. I just want to make sure that I had room to actually do it right here. 1, 2, 3, 4, 5, 6, 7, 8. And it doesn't matter where they go on your grid paper as long as they're there, right? So 8 rows with 1 in each row. So this one, instead of being long and skinny like this one is tall and skinny. Again, make sure you're staying right on that line. 8 rows times 1 in each row is 8 square centimeters. And there we have it. So finish up drawing your rectangles on your square centimeter paper. You should have 4 rectangles that we created the number sentences here, plus we did the 4 times 3 earlier. So on this paper, you should have a total of 5 rectangles on your square centimeter paper. But super, super job, boys and girls. I hope you had fun. I think that it's fun using the grid paper and drawing the rectangles and working with our tiles. So keep up the great work with area. See if there's things around your house that you can measure in area. If there is square tiling on your floor, or think of things that you could measure with area, and keep that math thinking going. And I will see you tomorrow.